Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge. The problem is optimal partition of a string. So we have a string S, and we want to partition it into one or more than that substrings, such that characters in each substrings are unique, right? So no letter appears twice, or appears more than once. And the goal of the problem is to return the minimum number of substrings in such a partition. So for example, let's take this string here. So what are the partitions? What is the minimum number of substrings that we can get out of it, with the rule that there are no duplicates? So we can do first AB, right? That's the first substring. We can do AC, no duplicates. We can do AB and then A, and that total is 4. So we return it. The other different way of doing it is to have just A, then BA, then CAB, then A, right? So that's the idea. The one thing to note here is that we have only lowercase English letters, and the length of the string can be up to 10 to the power of 5. Okay, so how do we tackle this? Okay, so how do we tackle this problem? Well, the first thing to think of is, well, let's just try to do it manually, right? So what would that look like? Well, let's just try to construct a substring. As long as it's valid, just keep going, right? Which makes sense. If adding a character to a substring will make the substring invalid, then just stop and start a new substring. And by invalid, we mean here that it has any duplicate letter, right? That's what we mean by invalid. And so if we take a look here, okay, so let's see here. So if we do that, then let's try first, we try AB, just A, and that's still valid, so we extend. So we have B, that's still valid, but if we try to add this A, it's duplicate with this A. And so we start a new substring. So we start a new one, let's say here. So we add A. Can we add C? Yes, not a duplicate yet. So we add C. Can we add this A? No, because it will be a duplicate with this one, so we don't add it, and we start a new substring. So every time we encounter a letter that will violate our condition of duplicate here, we stop and start a new substring. And so we try again here, A. Can we add this B? We can. Can we add this A? No, we can't. We can't add it, so let's just stop and start a new one. And so we stop here, and we start a new one from this A, sorry, and we are done, okay? And so how many we have here? We have 4, okay? So that's pretty straightforward solution, and it should work because we optimize, and we try to go as long as we can. Okay, so we guarantee that there is no better substring. So that's the idea here. Now, how do we do this? How do we implement this? Well, the main thing actually here we just go through the string one by one. The main thing that we need to think about here is how do we check that, for example, this A is in the previous substring, in the substring we have so far. So how do we check if this A is in this AB? The easiest thing to think about is, well, let's just use a set, right? Because then we can just do in one operation, we can just check if the character is in the previous, the current substring that we are looking at, right? And so we will just maintain the current substring in a set and just check, right? Now we also need to keep track of the count, but we don't need the strings themselves, the substring themselves. So let's just keep track of the count itself and not the substrings. And that's pretty much it. With that, we should be able to solve it. Now, in terms of time complexity, what is the time complexity here? We are traversing the string once, right? As you saw what I did here. So it's O1 time, and is the length of the string. Now, what about space complexity? Well, as we go, the only extra space that we used is this current set that holds the current substring. Now, what is this? Well, this current substring we can have a string that doesn't have any duplicates, right? So C, D, E, F, all the way to the end, right? In that case, is this current n or is it something else? Well, it's not n, because let's say if you have a multiple times, let's say if you have a like this, right? Then what will be in current? Each time current will contain only the letter a only, right? Because each time we'll start a new substring and we will reset our set. Okay, and so the only case where the biggest thing that current can contain is all the alphabet letters, all the lowercase letters, because the S has only lowercase letters. And so the only case, the maximum it can be is if a string has a streak of all the lowercase letters, then in that case all of them will be in the current set. Now how many are there of lowercase letters? Just 26. And so the worst case is having 26 letters in this set. And so our space complexity, since this is the only thing we are using, is of 26, which is just constant space. Okay. And yeah, so let's implement this and make sure it passes our test cases. Okay, so let's implement the solution we just saw in the overview. So we need a current set, right, that holds the current substring. And then we just go through the strings. And we need a count, right? For now, let's just initialize it to 0. Now, if the character is not in the current set, then we can just add it to the set, right? And then and that's pretty much it, because we haven't started any new string, so we don't know so we shouldn't increment count. But otherwise, if it's in the set, we need to stop the current substring, count it, and then create a new substring. So to create a new substring, we just reset the string, and then we add current, we add the character. And we also need to increment count because we just started a new substring, right? And then we, at the end, we want to return count. Now there is one edge case, which is what if at the end here, right? What if we started, let's say for example here, right? A, B, C, D, right? So what will happen is that we will find that it's not, A is not in the current set, and so we'll add it. We'll find that B is not in the current set, we'll add it. C is not in it, we add it. D is not in it, we add it. And then we'll exit the loop and count will be 0 still, right? That's because the only way we increment the count is if we get another duplicate, right? So how do we fix that? Well, we can just check here if current contain elements. So if current length is bigger than 0, then we want to increment the count, because that means we added characters at the end of S to current that we haven't counted yet, right? So that's pretty much it. Let's run this, and this looks good, but it's a little bit verbose. So how do we fix that? Well, the first thing is this is the same, right? So we can move it outside. So to move it outside, we can just put it like this. Now this one is empty, so we can just, instead of doing if else, we can just do the negation of this if condition. So just if current C is in current, we reset and then increment the count. Now how do we get rid of this one? Well, we can just initialize to 1 for the first substring, because the problem says that the string has at least one element. So we know there is the first substring, and then once we start a new substring, we just increment, and that will take care of that case and take care of this case as well. Okay, and that should be it. So let's run it. It passes here, so let's submit, and that passes our test cases. Yeah, so pretty straightforward and a greedy approach work here, and that's pretty much it. Please like and subscribe, and see you on the next one. Bye.